Guys, welcome to this video. This video we are going to see about the introduction to MXNet, and it is produced by TechnoWizards. So let me start. Okay, the general introduction to our MXNet model is Apache. It is an open source deep learning software framework which is used to train and deploy deep learning neural networks. It is scalable, aligned for fast model training, and supports a flexible programming model and multiple programming languages including C++, Python, Java, Julia, MATLAB, JavaScript, Go, R, Scalable, and etc. Which means this Apache MXNet is not only for Python, it is well supported in many of the languages which I have been mentioned here. So like it is also an open source network where like everyone can use it, and it in a different platform. So what is generally and exactly the MXNet library means? So it is a portable and it can scale to multiple GPUs and multiple machines. It is supported by public cloud providers including AWS and Microsoft Azure, Amazon. So this Amazon has chosen MSNet as its deep learning framework of choice at AWS. Currently, MXNet is supported by Intel, Baidu, Microsoft, Wolfram Research, and research institutions such as Carnegie Mellon, MIT, the University of Washington, and the Hong Kong University of Science and Technology. So many of them are using this MXNet library, so which is a very good thing that you should learn this actually to do many deep learning neural network programs, or like such a way like we can develop our skills by learning this MSNet library. Okay, what are the features of this MXNet library? Apache MSNet is a lean, flexible, and ultra scalable deep learning framework that supports state and the art of deep learning models, including CNN and LSTM. So, generally, MXNet will have these two features, which is called as CNN and LSTM. Both comes under deep learning neural networks, where CNN is used for to classify the images, like we can do classification, segmentation, and something we want. And what does LSTM do? LSTM do like that will be coming under natural language processing, where if we want to train an model which has a many large number of data set, we will be using it under LSTM. LSTM is nothing but long short term memory, where we have three sigmoid function and one tan function. So the model will be again, I mean, those are called as the activation function. So these model will be keep on training and training, and it will go under each and every step, and it will provide the output, so that will be very much accurate. Because of this much big process will be done in LSTM. So MXNet is a scalable one which is designed to be distributed on dynamic cloud infrastructure using distributed parameter server, based on the research like of this Carnegie Mellon University, Baidu, and Google, like they have been researched and saying, and can achieve almost with the multiple GPUs and CPUs. Okay, it is a flexible one. It supports both imperative and symbolic program, which makes it easier for developers that are used to imperative programming to get started with deep learning. It also makes it to use easier to track, debug, save checkpoints, modify hyperparameters such as learning rate, or perform yearly stopping. So it's a flexible one where we can use it to customize the program's feature, or the predefined model parameters, or the hyperparameters, which is nothing but we can change the tuning rate of the learning rate of a model. Say for example, my hyperparameter for the training of model of an image will be of something 0.1, means I can change the hyperparameter where alpha value to 0.2 or 0.3. So this is possible with MXNet model, and it is both imperative and symbolic programming language, I mean library. So to get started with deep learning, it is a very much useful library. You should learn this. Okay, then as we all As we already said, it will support many languages, such as it supports C++ for optimized backend to get most of the GPU and CPU available, and like several languages, Scalar, Clojure, Julia, Perl, Metal, JavaScript, and those are for the front ends. And the next point will be the portable, supports an efficient deployment of trained model to low-end devices for inference, such as mobile devices, IoT devices, serverless computing, and or containers. These low-end environments can have only weaker CPU or limited memory, uh, such as RAM, or should be able to use the model that were trained on higher level environment, which is called as GPU based cluster. Okay, so portable means we can do the project either say for example, like let me clear you, GPU will be the higher level environment and CPU will be the lower level environment. If we are doing a or coding in a low level environment, don't worry, with use of this library we can convert it to a higher level one. So that is what they are saying here. It is very much portable, like we can convert it, or like we can do it in a vice versa, where these are the several different firms where they are using this MXNet portably. So with IoT and serverless computing we can do this, and many more we can do with this library. So overview of the library will be, we are going to see what are the packages and deployment model and etc. Come, let's start with packages and models. So the first package will be Gluon, MXNet imperative interference for Python. If you're new to MXNet, like you should start from this Gluon library first. ND array API, which is used to NDA to manipulate data, and useful set of tutorials will be given in their official website. You can go and visit it. And then simple API, MXNet simple API has been depreciated. API documentation is still available for the reference, so you can go and check it out in their official website. So what and all the APIs and the packages model we are explaining in this video, I'm going to short it down, because in next part we will be going to see the practical implementation of the MXNet, so that the theory is not much required. If you want to learn more, you can visit their official website. So and then last will be Autograd API. How to use this automatic differentiation with Autograd API? Cool, right? Still now we'll be using this differentiable tool manually to get an output, but with this use of API, we can automatically differentiate, or like we can automatically do some particular task with this deep learning library or some function. This is cool, right? So next we are going to see about performance. First of all, improving the performance, how to get the best performance of the MXNet. So actually these links will be, like I'll be providing the link so that you can go and visit their website to know each and everything about it. Okay. Okay, so compression and MKL, DNN, TVM. So these and all you just need to take a look of this, and then deployment label and MXNet on ECI. So no need to worry. You just need to know their names, like at what server they are deploying, such as EC2 and SageMaker. I think probably this will be coming under Amazon Web Service. So they are having this deployment section, I think so. So that's all for today videos, guys.